Hello, everyone. Let me just share my screen first. Welcome to the Lesson 7 Office Hour. Right, so let me get back to the first page. Oops. My computer is a bit stuck. Give it some time. Okay. And let me fix the settings and then we'll start. Okay. So let's wait a minute for others to join. And then at 6:03, we will start. Walkthrough of CLSB and SPGS, everyone. So we will look at the first question. Oops, just get rid of this blue line over here. This one is CLGS first. Thanks. City of London. Okay. So here, the diagram below shows two overlapping rectangles. We have a small one and a large one. The question one is, calculate the area of the larger rectangle only. So hope you still remember the formula to find the area of a rectangle, which is length times width. And for this question, we only have the length. We need the width. The width, the 13 over here is not the width. It is part of the width. So how do we find the width? It's pretty simple. Okay, let's get stuck again. We just need to find this part. Yeah, we need to find the length of this part and then add the 13, and that will be the width. So I'll quickly do it for you, and I know it's no challenge for everyone. We have a 12 over here. We have a 7. So that means this missing bit will be 12 minus 7, which is 5. And then the whole width will be 13 plus 5, which is 18. And then 18 times 20, length times width, will give us the area, which is 360 square centimeters. Pretty easy. And then let's move on to the second question. Calculate the total shaded area that the rectangles cover. So this is an area with inclusion and exclusion, which is summer holiday term stuff, everyone. I hope you still remember. So we want the area of the small rectangle and then plus the area of the larger rectangle minus, I'll mark the special area in red, minus the area that has been overlapped once. Okay, we need to take away one of this overlapping area to give us the total shaded area. So let's find out the area for the smaller triangle, which is 12 times 9, sorry. 12 times 9, and then plus the area of the large rectangle, which is 360, and then take away the area of the red overlapping part. So the area of the red overlapping part, we know this bit, okay, let me change the color. This purple bit is 5. And then the width of the small red rectangle is 9 minus 5. So 9 minus 5, which is 4. So minus 4 times 5. This expression after calculation will give us the correct answer. Let's calculate. 12 times 9 is 108. And then plus 360 minus 20. So I'll write it down here. 108 plus 360 minus 20. We can do the subtraction first, which will be easier for us to calculate. 108 plus 340, and that will give us 448. There, that's question number 11. Moving on to the next one. The diagram below shows a rectangle and a square. So this is the rectangle and this is the square. We don't know the dimension, the side length of the square yet. So if they have equal perimeters, this is a condition we need to use. We can find the perimeter of the rectangle first, which is 30 plus 70, altogether multiplied by 2. Hope you still remember the formula to find the perimeter of a rectangle. And that will give us, this is 100 in the bracket, and then 100 times 2 is 200 centimeters. Pen is malfunctioning for a bit. 200 centimeters. This is the perimeter for the square as well. And the formula for us to find the perimeter of a square is the side length times 4. So we can find, okay, in the reverse direction, we can find the side length by dividing the perimeter by 4. So 200 divided by 4, over 4. I'll write it in a fraction. And this is 50. This will give us the side length, all right, represented by small letter a. It is 50 centimeters. This is 50. This is 50. So we know the dimension of this square right now is a 50 by 50 square. Then the question is asking for what is the difference in their area. So the area of a square is side length squared. So it's 50 squared, which is 2,500 square centimeters. And then the area for the rectangle is 30 times 70, length times width, which is 2,100 square centimeters. And we can get the answer through observation. The difference between 2,100 and 2,500 is 400 square centimeters. Good. And then moving on to question number 14. A, find the size of angle A in the diagram below. So we're trying to find this angle over here. Okay. So let's see, which are the unknown angles in this diagram? So there are a total of 1, 2, and then 3, 4, 5, 6. 6 unknown angles. So I know that you can all get the correct answer by using the basic method of, the triangle has a sum of interior angles of 180 degrees. You can use this. You can use this and then find the angle A. But today I'm going to introduce a better method or a cooler method for you to solve A quicker. It is called the 8 model. This model over here, it looks like an 8, and we can find it in this diagram. Okay, I'll have to outline it so you can see it. Let me see if I can find my straight line tool. There we go. The straight line over here. Oops, straight line tool is gone. I have to click on it again. Straight line over here. And then straight line over here. Okay, it's taking too long. Great. So here is our 8 model. So the 8 model is basically because these 2 lines are straight lines. Okay, these 2 red lines, they are straight lines. And remember, in summer holiday term, we learned a very important theory that tells us that with 2 straight lines intersecting, it gives us 2 pairs of opposite angles, and opposite angles are equal to each other. So that means this angle is equal to this angle. Why? And I write on it. Okay, now it's good. So the red angles are equal to each other. And because the sum of all 3 angles in a triangle is 180 degrees, then we can say, let me write in another color. So A plus 17 degrees equals to 19 degrees plus the, mark this green. So the green angle, this is what we represent angle in mathematics. Then write this expression over here. So angle A, the target angle we want, plus 17 degrees equals to 19 degrees plus the green angle. We can find the green angle very easily because we know this is a right angle and the green angle is just a right angle, subtract 72 degrees, which is 18 degrees. So just substitute this green angle with 18. You see, the rest is just some addition and subtraction. You can find the angle A in no time. Why can we write this? It is because these two are both equal to 180 degrees minus a red angle. Okay, this red angle and this red angle, they're the same. Okay, so we can just use one red angle to represent them both. And then we have these two equations. So let's find the angle A. Angle A will be 19 degrees plus 18 degrees minus 17 degrees. Remember, plus 17 degrees move to the other side of the equation, becomes minus to change the sign. So A will be 37 degrees minus 17 degrees, and which will be 20 degrees. That's the answer. And question B, would you describe how would you describe 100 degree? Acute, obtuse, or reflex? And we know acute angles are angles that are less than 90 degrees. So between 0 degrees and 90. And obtuse angles are angles between 90 degrees and 180 degrees. And reflex angles are angles between 180 and 360. So 100 falls in the obtuse region, so it's obviously an obtuse angle. Good. So no question. So that's this question. Let's move on to question number 16. This one is an interesting question, especially with the second question. Question number 1. A box measures 20 centimeters by 11 centimeters by 15 centimeters. Calculate the volume of the box. So we have the 3 dimensions of this box, and actually we just learned it with lesson 5 in autumn term. 3D shapes, find the volume of a rectangular cuboid. The formula, hope you still remember, is just multiply the 3 dimensions together, 20 times 11 times 15. We can do the 20 times 15 first, which is easier, which is 300 instead of 30. Be careful, everyone, not to miscalculate. And then it will be 300 times 11. The answer is 3,300 cubic centimeters. Then question number 2, a string is tied around the box with the bow at the top. The bow at the top is this one over here. If the length of the bow is 8 centimeters, so we don't, so if you untie this bow and then stretch it, the total length will be 8 centimeters. Calculate the total length of string used. So apart from this 8 centimeter bow, we need to add all of these lines together to find the total length of string used. And that includes, so the height, the 15, one of them, okay, this is 1, this is 2, this is 3. On the left-hand side is covered, we cannot see it. And then one on the back side, we cannot see it as well. So 4 of the height, 15. So 15 times 4 first. And then vertically, we have 20. We have the lengths. How many? Let me change the color. So the red ones, we have 1 of them, and then 1 on top, and then 1 at the bottom. Not see, it's been covered. The 2 of them. So 2 20s. And then finally, let me change the color. The green ones. The green ones are the vertical ones. Okay. The ones that are perpendicular to the 20, which are the 11 centimeters, the widths. We have 1 and then 2 over here. So plus 11 times 2. And remember, don't forget the 8 centimeter bow on top plus 8. That should give us the correct answer, which is, this is 60. This is 40. This is 22. And this is 8. And 22 plus 8 is 30. So this equals to 60 plus 40 plus 30. 60 plus 40 is 100, and 100 plus 30 is 130 centimeters. Remember the units. So that's question number 16, and we can move on. Moving on to question number 17. So we have all these numbers from 20 to 28, and write one number from 20 to 30 that satisfies the description below. Some numbers are used more than once. So first of all, which one of these numbers is a prime number? Yes, Kiki, you have a question.
For the question 17, the number says 20 to 28, but then the question says write one number from 20 to 30. So does that include 29 and 30?
29 and 30. Let me have a look. Well, I think, yeah, this question is a bit yeah, this question is indeed a bit confusing. I'll give you that, because the question says from 20 to 30, but instead we only have from 20 to 28. The 29 and 30 are missing over here. Yeah, so I'll add the 29 and 30. Don't worry. My pen, here it is, 29 and 30. And then, first of all, prime numbers. So I'll write down all the correct answers, although the question only requires you to write one number. So you can just pick one of them and then write it during the exam. So prime numbers between 20 and 30, this is something you should remember in your mind. So all the prime numbers between 20 and 30 are just two of them. First of all, they should be odd numbers. So the even numbers, the 20, 22, 24, we can all cross them out. And then the odd numbers, the 21, 23, not all of them are prime numbers. Actually, only two of them, so 23 and 29. Okay, two of them are prime numbers. You can pick one and write on the blank when you're in an exam. And then question number 2, cube numbers. Cube numbers, there's actually only one between 20 and 30, which is 27. Again, this is something you should remember, should be happy with. There is no clever method for you to get the cube numbers. There is no analysis you can do. Oh, well, perhaps there is. Let's see. So cube numbers, 1 cubed is 1. 2 cubed is 8. These are all between 1 and 10. 3 cubed is 27, which is the only cube number between 20 and 30. Because 4 cubed will be 64. Okay, so if you want to analyze, if you don't want to remember it, this is the way you analyze. And then for square numbers, there's only one, which is 25. Again, if you want to analyze, you can do 1 squared, and then 2 squared, 3 squared, 4 squared, and then finally the one that meets the question's requirements, 5 squared. 25. 6 squared is 36. It's more than 30, just 25. And then Fibonacci numbers. Fibonacci is when you add numbers together. So 1 plus 1 is 2. So the first 2 terms added up to give the third term. 1 plus 1 is 2. 1 plus 2 is 3. And then to get the next term after 13, we do 8 plus 13, which is 21. So 21 is a good answer. You can write it down. And the next one is 13 plus 21, which is 34. So it's more than 30. So only 21 meets our demands. Write it down here. Right. As the question has mentioned, some numbers are used more than once. Let's look at the next page. So we have 3 more questions over here. Again, I'll write the 29 and the 30 over here. So question number 5, write triangular numbers. So triangular numbers are, if we are going to represent, so draw triangles with dots, okay, we start with 1, so 1 dot, and then 3 dots is 1, 2, 3. See, this is a triangle over here. And then 1, 1, 2, 1, 2, 3, altogether 6 dots. So it's a 3-layer triangle like this. Okay, this is called triangular numbers. So as you can see, with the first triangle is just 1. With the second triangle is 1 plus 2. With the third triangle is 1 plus 2 plus 3. And with the fourth one is 1 plus 2 plus 3 plus 4. So we can we can keep writing. This is 1 plus all the way to 5. And then 1 plus all the way to 6 is just adding a 6 to the 15, which is 21. Then the next one will be 21 plus 7, which is 28. Then 28 plus 8 is 36. So all of these numbers, the only two that meets our requirements are these two, 21 and 28. These are triangular numbers. And then perfect numbers. A perfect number is a number whose factors, not including itself, this is important, adds up to itself. So let's see. 20, all the factors of 20, we can write them down. 1, 2, 3 is not, 4 is 1, and then 5, then 10, then 20 is a factor, but not including itself. So 1 plus 4 plus 5 is 10. 10 plus 10 is 20. 20 plus 2 is 22. It does not add to itself. So no, 20 is not. And then 21. 21 has factors 1, 3, 7, and itself, but not including. So add them together. 1 plus 3 plus 7 is 11. It's not itself, so no. 22, we have 1, 2, 11, and then 22. So it is 11 plus 1 is 12. 12 plus 2 is 14, so no. And then 23 is a prime number, definitely no. And then we can cross away the 29 as well, since it's a prime number. 24, we have 1, 2, 3, and then 4, 6, 8, 12. This will give us 4 plus 6 is 10. 12 plus 8 is 20. 10 plus 20 is 30. It's way larger than 24. Okay, it's definitely larger. No, 24 is not what we're looking for. 25. So for 25, we have 1 and 5, actually. It has itself, but we're not including itself. So it's just 1 plus 5, which is 6. It's less than 25, so no. Then 26 is 1, 2, 13, and itself. It adds up to 16. So no, still less. 27, we have 1, 3, 9, and itself. It adds up to 13. No, it's less than. 28, we have 1, 2, 4, 7, and then itself. And then 14. Let's see if this one does the work. So 1 plus 2 is 3. 3 plus 7 is 10. 10, and then 4 plus 14 is 18. 10 plus 18 is 28. Okay, we finally found our number. 28 is the perfect number. All of its factors, not including itself, add up to itself. Okay. And the last one, powerful numbers. A powerful number has the property that for every prime number which divides into it, that prime number squared also divides into it. So, for example, 16 is a powerful number because both 2, the smallest prime number, and the prime number squared, 2 squared, which is 4, are its factors. So we're basically looking for numbers with factors 2 and 4 at the same time, or you can have 3 and 9 at the same time, which is also possible. So we can include 20, we can count 20 because it has factors 2 and 4 over here. We cannot count 21, not count 22, not 23. We can count 24 because it has 2 and 4. Cannot count 25, cannot count 26. We can count 27 because it has factors 3 and 9. And also we can count 38. It has 2 and 4. Again, not 29. Let's see if we can count 30, shall we? So the factors of 30s are, 30 is 1, 2, 3, and then not including 4, but we do have 5, and then 6, and then 3 times 10, 2 times 15. We have these factors, 1, 2, 3, 5, 6, 10, 15. So no, 2 and 4 not included, 3 and 9 not included. Is it a perfect number? Let's check. 1 plus 2 plus 3 is 6. 6 plus 5 is 11. 11 plus 10 is 21. 21 plus, okay, so it's definitely larger than 30, so it's not a perfect number either. 30, cross it out. So for powerful numbers, we have 20, 24, 27, and 28. Okay, and that's question number 17. That's it. We can move on now to the last question, I think. This question is, is testing if you're happy with your BIDMAS. Okay, everyone remember BIDMAS? I'll write it down here. Everyone tells me they're confident with BIDMAS, but still we still receive tons of mistake with BIDMAS questions. Yes, Jaden?
You spelled BIDMAS wrong. You spelled BIMDAS.
Oh yeah, BIMDAS. That's BIMDAS. Yeah, thank you very much. So BIDMAS, thank you very much. I'll write it. The D and M are in the wrong places. Swap them. Yeah, BIDMAS right here. So B stands for brackets like these. And then I is for index, yeah, or indices. For example, 2 squared. The 2 over here, this is an index. The one you write on the top right corner. And then D and M, they are, so whichever comes first, division or multiplication. And then A and S, these two are a group. So D and M, they are a group. And A and S, they are a group. Whichever comes first, addition or subtraction, multiplication or division. Okay, so this is our priority from left to right. So let's see this question. How should we solve it? So we first solve the brackets, whatever is in the bracket. Okay, and the 4 plus 4 is in the inner brackets. Yeah, the inner bracket has higher priority than the outer bracket. So 4 plus 4 is 8. Okay, so we have 4 minus brackets 8 divided by 2, 8 divided by 4 brackets, and then solve whatever's in the brackets. 8 divided by 4 is 2, so it's 4 minus 2, and 4 minus 2 gives us 2. Okay, this is the correct calculation order that we should all follow. Moving on to I think this is the last question for City of London. So 1001 equals to A times B times C, where A, B, and C are prime numbers. This is actually stuff from summer holiday term, where I think it's the first lesson in summer holiday term where we introduce lots of number pairs. And I hope you still remember that we have introduced 2 special number pairs. The first one is 37 times 3, which is 111. And the second pair is this one, 7 times 11 times 13, which is 1001. Okay. It will be really beneficial for you if you can remember these 2 special number pairs. It will help you a lot, speed up your problem solving process in the exam if you're happy with these 2. And we need to know which so 7, 11, and 13, which is A, which is B, and which is C. It says here, C is bigger than B, C is bigger than B, and B is bigger than A. So if we write them in ascending order, 7, 11, and 13, so it's A less than B less than C, and that is 7, 11, and 13. So A is 7, B is 11, and C is 13. All right? So moving on. Oh, yeah, we still have another question number 20. Given that 2357 multiplied times 99 is 233343. Find question number 1, 233343 divided by 99. So this is testing you the properties of multiplication and division. So this is a multiplier. This is a multiplier. This is the product. The product divided by 1 multiplier is obviously the other multiplier. So it's 2357 for the first question. And then the answer for the second one. So if I shrink 1 multiplier by 10 times, then the properties of multiplication tells us that the product will also shrink by 10 times. So you can either divide by 10, or you can move the decimal point, which is after the 3, the last 3 over here. We can move the decimal point 1 digit to the left, right? So the answer shall be 23334.3. Okay. Right, that's question number 20. We can move on now. Oh, there's still one. Okay, question number 21. The symbol has a special meaning in arithmetic. And A symbol B means add A and B and then multiply by A. For example, 4 symbol 2 equals to, first of all, add them together, 4 plus 2, which is in the bracket right here. And then multiply by a, the number on the left. So multiply by 4 outside the bracket. So it's 4 times 6 is 24. So question A, work out 4 symbol 5. So again, in the bracket, we add them together first, 4 plus 5. And then outside the bracket, we'll multiply by the number on the left, the 4. So this is 4 times 9, 36. That's the first question. And question B, work out 4 symbol brackets, 3 symbol 2 bracket. So for this one, I recommend that we still apply the rules of BIDMAS. Solve whatever's inside the brackets, get that result, get that one number, okay, and then do 4 symbol that number instead of doing them all at once. Okay, don't write 4 symbol and then so 3 times 3 plus 2, because this is easy for us to make mistakes. Instead, calculate 3 times 3 plus 5 bracket 3 plus 2 bracket first, which is 3 times 5, which is 15. So 4 symbol 15. Then in the bracket, we have 4 plus 15, which is 19, and then multiply 4, the number on the left. So it's 4 times 19, and that will be 76. You can do 4 times bracket 20 minus 1, which is 80 minus 4, so it's 76. That's the answer. Then for the last question, work out the value of P such that 6 symbol P equals to 78. Again, we can write the expression including P, and which will be 6 plus P in the bracket, and then multiply 6, the number on the left. This is 78. Open the bracket, distribute 6 into each terms inside the bracket will give us 6 times 6, 36, plus 6 times P, 6P, equals to 78. Then 6P equals to 78 minus 36. Move the 36 to the other side of the equation. The 78 minus 36 gives us 42. Remember, it's not 32 over here. Careful not to miscalculate. And then 6P equals to 42. 6 times P equals to 42. P equals to 42 divided by 6, which is 7. So the answer is 7. P equals to 7. Okay, moving on. 4 bells ring at intervals 2, 8, 7, and 11 seconds. If they are all rung at the same time, how many seconds will pass before they all ring at the same time again? So we should show some justification for our answers. So we have intervals of 2, intervals of 8, intervals of 7 and 11. It's basically just asking us to find the lowest common multiple, the LCM of the 4 numbers. Because consider this one. We have, for example, we have intervals of 2. So 1 interval, 2 intervals, 3 intervals, and 4 intervals. We consider 4 intervals of 2 first. And then for intervals of 8, 1 interval of 8. Okay. So now the bell, the first bell and the second bell, they will ring at the same time. The first bell and the second bell will ring at the same time. And this is at 8 seconds. Yeah, the 2 bells will ring because 8 is a multiple of 2 and a multiple of 8 at the same time. So knowing this, let's try to find the lowest common multiple of the 4 numbers, 2, 7, 8, and 11. And we don't actually need to consider 2 because 8 itself is a multiple of 2. So any number that is a multiple of 8 will definitely be a multiple of 2. So throw the 2 away. Just consider the 3 numbers, 7, 8, and 11. So first of all, the common multiple, the lowest common multiple of 7 and 8, because they are consecutive numbers, they're next to each other. That means they're co-primes, meaning they have no other common factors other than 1. So that means the LCM of 7 and 8 will just be the product of the 2 numbers, 7 times 8, 56. And then we try to find the LCM of between 56 and 11. So again, 11 is a prime number, meaning that it has no other common factors with 56 other than 1. So again, the LCM between 56 and 11 will be 56 times 11, which will be, so here, for those who are in my class, I have introduced this very handy way for you to find any 2-digit number, multiply 11, and find the product quickly. You can draw this little symbol, this little M shape, below the 2-digit number. The 6 goes to the right. The 5 should be going to the left, but because in the middle we have 5 plus 6, which is 11. That is more than 10. So we only write 1 in the middle and then carry a 1 to the hundredths digits. So 5 plus 1 is what we should write on the left, 6. So 616 seconds. That is the answer. After 616 seconds, the 4 bells will ring together at the same time again. All right. Moving on. Okay, finally, we are at St. Paul's Girls' School now. Let me just get the lights back on. Actually, you can take a 2 or 3 minutes break, everyone.
You're muted, so nobody can hear you. You were muted just then, so nobody could hear you.
I said take a 2 minutes break because we just finished the City of
All right,
London
yeah.
school. All right, that's about time for a rest. I've got the lights back on, and I just checked the answers for this question. And yeah, for the first one, first of all, I have to answer. So one of the students, I remember is Kiki, so mentioned that the question only gave from 20 to 28, but what says here is from 20 to 30. So yes, we this is what we should stick to, 20 to 30. The question, the answer says there's a mistake in the question. It should be 20 to 30, include 29 and 30. And no problem with this, no problem with this. Powerful numbers, no problem. Oh, yeah, sorry, the perfect numbers, powerful numbers. For powerful numbers, we should, yes, Cindy?
Well, I just wanted to ask about question 14, because I'm not sure if I really get it.
Oh yeah, sure. No problem. If you have any questions, remember to stay at the end of the office hour. I will answer all of the questions all together at the end of the office hour. All right. Yeah, and for this one, I just need to make a little change to add something to the powerful numbers because we are not including the itself for powerful numbers. So of course we can include 25 in it. Yeah, because 5 and 25, yeah, it can be included. And of course, we can look at 4 and 16 as well. So let's find if there are any numbers which has 4 and 16 as its factors. in them? 20, no. 21, no. 22, no. 23, prime number. 24, 4, no. 16, 25, no. 26, no. 27, no. 28, no. 29, prime number. 30, no. So this one we can cross out. But just remember 5 and 25. Yeah, we can include the number itself. Number itself is a factor of itself as well. So 25 is also a powerful number. For every prime number which divides into it, also divides into it. Yeah, that's the powerful numbers. Let's move on to St. Paul's Girls. Right over here. The first question, the numbers 1 to 800 are arranged in order in a table. So we have 7 columns and multiple rows, not just 4, there are lots of them. Only rows 1, 2, 3, and 4 are shown, but there are many more rows. So question A, what do you notice about the numbers in column 7? So let's see, in column 7, we have 7, 14, 21, 28. We're going up by 7 each time, and they are all multiples of 7. So the answer is multiples of 7. And B, question B, what is the last number in row 8? So last number is numbers in column 7. So column 7 in the first row is 7, which is 7 times 1. The second number so the last number in row 2, which is the second number in column 7, equals to 7 times 2, which is 14. And then the last number in row 3 is 7 times 3. The last number in row 4 is 7 times 4. So the last number in row 8 will be 7 times 8, which is 56. Then question C, what is the last number in row 100, which is the same. We can get the answer using the same operation in question B. So it's 7 times 100. So the answer will be 700. And then D, 77 is the last number in which row? So 77 is a multiple of 7 as well. So that means it must be in column 7. We divided by 7 to find out which row it is in. So 77 divided by 7 is 11. So row 11. Okay, my pen is not working. There. And moving on, we're not finished yet. So the second half of the question, question E, what is the number in row 12 and column 3? So row 12, column 3. Let's look at column 3, shall we? So in column 3, we have 7, 10, 17, 24. Again, we're adding 7. We're going up by 7 each time. That means this is an arithmetic progression. And I hope you're still happy with what we learned in lesson 4, autumn term, arithmetic progression. The general term method, we can find this number in row 12, column 3, quickly using the general term method. The first step in the general term method, to find the general term, is identify the common difference, which is 7 in this case. And then the second step is to write an n after the common difference, 7n. And then we will generate the 7n sequence, which is just the numbers in column 7. The multiples of 7, 7, 14, 21, 28, etc. And then the last step is to compare the 7n sequence with the sequence we actually have over here. So we say 7 to 3, 14 to 10, 21 to 17. For each term, we are taking away 4. So 7n minus 4. Yeah, so the 7n sequence, for every term in the 7n sequence, we want to take away 4 so that we get the sequence we have over here, the 3, 10, 17, 24, right? So 7n minus 4 is the general term. And n is the row number right here. So row number 12 means n equals to 12. 7 times 12 minus 4 is our answer. 7 times 12 is 84. 84 minus 4 gives us the number 80. All right. And then question F, what row and column will contain the number 400? Now, we know this times we're doing it in the opposite direction. We know the number. We want to find what row and column it will be in. So the way we do it is we look at how many numbers there are in each row. That means, so one row is one cycle. And then there are 7 numbers in each row, meaning there are 7 numbers in one cycle. So we use 400, which is the total number of numbers we have, divide by 7, divide by the numbers of terms or the number of numbers in every cycle. And that will give us, so 400 divided by 7, 40 divided by 7 is 5. 5 times 7 is 35. 40 minus 35 gives a remainder of 50. 50 divided by 7 is 7, which with a remainder of 1. So it's 57 with a remainder of 1. So we know that we have now completed 57 complete cycles or 57 complete rows. We have fill in 57 full rows with 7 numbers in them, with a remainder of 1 number. Okay, if we have no remainder, everyone, we will be stopping at the last number of row number 57. But we have another remainder, meaning we need to go 1 further. That brings us to the next row, which is row number 58. And at this position over here, column 1. Yes, Kiki, you have a question?
How did you get column, like from column 7 to what? I mean, like, how do you get the columns?
The columns, okay, so you see here, divided by 7 is because we know in each row, sorry, not column, the row. All right, Cindy, you have a question?
I don't get E.
Yeah, well, I will go through E again at the after I finish answering this question. Don't worry. So how we got column 1 is because we have 7 numbers. Sorry. We have a total of 400 numbers. All right, we want to fit them into this table. So we fit 7 numbers first, and that is 1 complete row. We fit in another 7 numbers, and that is 2 complete rows. We fit in 57 times 7, which is 399 numbers, and that is 57 complete rows. Is it clear for everyone? Yeah, 57 complete rows. And for the last number, yeah, the last number at row 57 will be 399. But have we finished? We don't want to know the position of 399. We want to know the position of number 400, which means we will need to go to the next row. This 399 is at row number 57. So we need to go to the next row, row number 58. All right, and then go from column 7 back to column 1, right? Because 7, after 7 is 8, we go back to column 1, right? So row number 58, column 1 is where we have the 400. Okay, hope this is clear. And for E, right, I'm not sure if all the other teachers mentioned the general term method in lesson 4 autumn term. But this is the general term method. My students definitely know this because I mentioned it during the autumn term lesson 4. This is a really handy method that you can use when you're trying to work with arithmetic progression. Right, so we have a sequence. If you look vertically at column 3, we have 3, 10, 17, 24. Okay, 3, 10, 17, 24. This is an arithmetic progression because we are moving up by 7, a fixed amount each time. We're going up by 7 every time. So the 7 is the common difference, and the whole sequence is an arithmetic progression. It's an arithmetic sequence. We can represent any term in this sequence using the general term 7n minus 4, right? Whichever term, name it yourself. I can represent it with 7n minus 4. The n is the number, is the term number. So for 3, n equals to 1 because it's the first. For 10, n equals to 2 because it's the second term. For 17, n equals to 3 because it's the third term. And then for 24, n equals to 4 because it's the fourth term. All right. For example, 3, the third term. 17, we can do 7 times 3, n is the term number. Take this one, plug it in, 7 times 3 minus 4, which is 21 minus 4. You see, we get 17, right? Same goes for every other term in this sequence. And in this case, the term number, the first, the second, the third, it's just the row number, you see? Row 1, row 2, row 3, row 4, row 5, row 6, row 7. Right, that is n, what we have here, n. So in row 12, n equals to 12, we have 7 times 12 minus 4. And 7 times 12, if I didn't calculate wrongly, yeah, which is correct, is 84. 84 minus 4 is 80. So the number in row 12, column 3 will be 80. Right here. Okay, We don't have enough time, so I have to move on. If you have any questions, again, you can feel free to stay with me at the end of the office hour and ask me. So question number 2, you are told that N5 means add up the first 5 counting numbers. So N5 is, so the first 5 consecutive numbers, 1, 2, 3, 4, 5. O3 means add up the first 3 odd numbers. E4 means add up the first 4 even numbers. So E7 means add up the first 7 even numbers. So we have 2, 4, 6, 8, 10, 12, 14, 16. Is this 7? 1, 2, 3, 4, 5, 6, 7. Okay, that's 4, right? So 14 is where we end. And again, this is knowledge from lesson 4, arithmetic progression. How we find the sum of an arithmetic progression. It's simple. Just take this first term, take the last term, first term plus last term, 2 plus 14 times the number of terms, 7 divided by 2. So it's 16 times 7 divided by 2. We can do 16 divided by 2 first, which is simpler. That is 8. 8 times 7 is 56. So the answer is 56. And then for the next one, N8. N8 means add up the first 8 counting numbers. It is 1 plus all the way to 8. So the first term is 1. The last term is 8. The number of terms is 8 divided by 2. So it's 8 times 9 divided by 2 is 72 divided by 2 is 36. The answer is 36. And for the last one, N9. N9 is 1. So it's just 36. We know what's 1 plus all the way to 8. We just need to take that sum, the 36, and then add a new number, the 9. Yeah, it's 1 plus all the way to 8, and then plus a 9. This we already know is 36. So N9 equals 36 plus 9, which is 45. The answer is 45. Okay, moving on. So question B, find the value of N401 minus N400. So it's basically the same thing, yeah? There is no difference between finding N401 minus N400 and N9 minus N8. You see? N400 is 1 plus all the way to 400. And the N401 is 1 plus all the way to 400 plus a 401. Okay, let me write over there. Plus 401, this is N401, and then 1 plus all the way to 400, this is N400. So if we take away N400 from N401, we're just canceling out the previous part, the 1 plus all the way to 400. So what's left will be just the 401. So the answer for question B is 401. Then for question C, there's a different way of finding the O, the results of O. This again is what I mentioned, what I taught in lesson 4, autumn term, arithmetic progression. So for odd number sequences that starts with 1, you see, 1, 1, 3, 1, 3, 5, 1, 3, 5, 7, 9, 11, 13, right? We can quickly find the sum of the sequence, yeah, all the numbers added together by taking the number of terms. So for 1, it's just 1 term. For 1 plus 3, it's 2 terms. For 1, 3, 5, it's 3 terms. And then for this one, it's 7 terms. Yeah, and then square. Yeah, square that number. So take the number of terms and then square it. That will give you the sum of all the numbers in this odd number sequence. And you see, the number of terms is equal to the subscription over here at the bottom right of O. Okay, so if it's O1, then it'll be just 1 term. So it's 1 squared, the sum. If it's O2, then it will be 2 squared. So the sum will be 2 squared. If it's O3, then the sum will be 3 squared, and etc., etc. So O13 means, sorry. So O13 means we have 13 terms altogether. Then the sum, or the value of O13 will be 13 squared, which is 169. Yeah, hope you still remember your square numbers from 1 to 20. Okay, moving on. We are told that N5, question D. So notice that N6 can be split into 2 parts to make the calculation easier. The N6 is 1 plus 2 plus 3 plus 4 plus 5 plus 6. And we can split it into odd numbers added together and even numbers added together. And we know odd numbers added together is 1, 3, 5. It's O3. And then even numbers added together is 2, 4, 6. It's E3. So you see, we can split it. We can split the 6 into 3 and 3. Okay, we can split the N into O and E. So N10, following this pattern, is O5 plus E5. Okay. And then E, we are told that N200 is 20100 and N401 is 80601. Use this information to work out the following. So E100. E100 should be a result after splitting. Okay. So we can write what we know over here. N200, according to question D, equals to O100 plus E100. And if we want to find E100, we can simply move the O100 to the other side. It's N200 minus O100. And 200, we already know it's 20100. We just need to find O100. And if you remember from the previous slide, we already know a simpler way to find O100 is just take the subscription, whatever's next to O, whatever number's next to O, and then square it. That will give you the sum or the value of O13 or O100, for example. Then for O100, it will be take away 100 squared. Then this will be E100. So E100 will be 20100 minus 100 squared is just 1 followed by 4 zeros. And that will be 10100. Okay, easy. And then for E200, for E200, we want E400. Right? Sorry, N400, because we know N400 equals to O200 plus E200. But we don't know what N400 is. We only know what N401 is. And now the previous question again kicks in, right? Question B, we want to find the value of N401. And so the difference, yeah, N401 minus N400 is just looking for the difference between these two. Okay, so we know the difference is 401. Let's move back over here. So N401 minus 401 is N400. Okay, and we know N401 is 80601. So 80601 minus 401 gives us N400, which is 80200. Okay, so 80,200. This we know is 80. So N400 is 80200. We can write over here. Oh, sorry, not 400, but 200. And then minus O200. O200, the value should be 200 squared. Okay, so it is 80200 minus 200 squared is 4, followed by 4 zeros. So the answer should be 40200. Okay, that's E200. Yeah, I hope I didn't make any calculation mistake. Yeah, that's right. Okay, let's move on to the next question. So question number 3, the letters on the 7 cards below have a number 1, 3, right? Kiki, yeah, you have a question?
Sorry, what was the last question's answer?
Here. So 10100 and 4020.
Okay. Thank you.
Yeah, you're welcome. Then let's move on to the next question. Let me have a look. Right, so we have St. Paul's. We have 7 cards, ST, capital letter S, small t, capital P, and then small a, small u, small l, small s. Okay, this capital letter S won't do us any good because you see the 3 conditions given in the question doesn't involve any capital letter S, so don't need to look at it. They all have a number on the back from 1 to 7, but not in order, not like 1, 2, 3, 4, 5, 6, 7. Right. And then what's given in the question, what's given to us is if S has the number 1 on the back, so that means S is 1, then we can have a look at the 3 conditions given to us. S plus A plus T, they add up to 8. So S is 1, then A plus T is 7. We can write it over here. All right. And then S plus A plus P is 9, right? So if we write S plus A plus P, and we take away S plus A plus T, and that will be 9 minus 8. You see, the difference is 1, and that difference is the only difference between P and T, capital P and small t, yeah? The S and A, they're all the same, so there's no difference. And the only difference here comes from the difference between P and T, okay? And T is the smaller one because it adds up to a smaller number. So P, we can write over here, P equals to T plus 1. This is what we get, okay? And at last, looking at the third sentence, the third condition given to us, L plus A plus P add up to 11. So again, A and P, they're the same, no difference. The difference comes from, the two difference comes from the S and L, okay? And the L add up to a larger number, meaning L is larger than S by 2, because 11 minus 9 is 2. So L equals to S, 2 plus S. And we know S is 1, that means L equals to 3. So we can write down all the S and L in numbers. This is 1, this is 1, this is 3. Okay. And then with this, we can actually write down all the values of all the cards. So 1 plus A plus T is 8. That means A plus T is 7, right? So we have these choices for for 7. For two numbers add up to 7. We can have 1, 6, 2, 5, 3, 4. 4, 3, 5, 2, 6, 1. We cannot have 1, 6 because S is 1. We cannot have 3, 4 because L is 3. Yeah, we can have, so that means we can only have 2, 5. Yeah, or 5, 2. Yeah. So anything that involves 3 or 1 won't work, because T cannot be 3 or 1 either. Yeah. 1 and 3 taken and occupied by S and L. So what's left for us? The choices are only 2 and 5 or 5 and 2. So let's say A is 2 and T is 5. All right. Then this is 2. And then that means P will be 7. Then if A is 2, then P will be 6 over here. So question A, we can solve it now. What does SALT add up to? Then this is 1, S is 1, A is 2, L is 3, T is 5. So this is 2 plus 3 plus 5 is 10. 10 plus 1 is 11. So first question, answer is 11. And for the second question, we're just adding another P. Yeah, SALT is this, so still remains the same. So it's 11 plus P. P is 6. So the answer is 11 plus 6, which is 17. All right. And then you may ask, how about when A is 5? Let's see when A is 5. Will the answer be different? All right. My pen is a bit glitchy today. Let's give her some love and patience, everyone. Right. So when A is 5, then T is 2. A is 5, P is 3, A is 5, P is... Right, P cannot be 3 over here, you see? Yeah, because 3 is taken by L, so that means A can only be 2. Yeah, that is the only answer. Right, so 1, 2, 5, 1, 2, 6, and 3, 2, 6. Good, that's this question, and let's move on. So we are told that opposite faces of a cube add up to 15. Find the sum of the faces that border with the marked corner. So this is a 3D diagram, everyone. This is not a hexagon. This is when we are looking at one corner of a cube. Okay. So for example, the sum of the faces over here is 3 plus 5 plus 9 is 17. Then question A. Find the sum of the faces that border with the marked corner for the following. So right now, the dot, yeah, the marked corner is over here. Okay, then the sum is not 3 plus 5 plus 9 anymore. We need to find, okay, let me draw the covered parts. the unseen parts, right? So we'll need the bottom side and then the back sides, the opposite side to 9, and then the 5. Okay, the bottom side is opposite to 3. And we know, we are told that opposite sides always add up to 13. So opposite side to 3 must be 10. Then the bottom side will be 10. And then opposite side to 9 is the back side, the one we cannot see, is 13 minus 9, which is 4. Okay, so we have 5, 4, and 10 for the 3 sides for the mark. Okay, let me draw it. It should look something like this. Part of my poor drawing. The pen is not doing me any good today. And so we have 5 over here, and then 4. Then yeah, actually we should have 10 at the bottom, but top bottom doesn't matter. This one is the marked corner. The sum will be 10 plus 4 plus 9, 19. Okay. Then next one, we have the marked corner is at 4. Is it here now? Again, I have to draw all the unseen faces. So we want 4 and the opposite side that's been blocked, opposite side of 5, which is right here, and then the bottom side. So the opposite face of 10, the bottom side, is obviously 3, that we already know. And the opposite side of 5, because we know they always add up to 13. So it must be 13 minus 5, 8. Okay. So the 3 sides this time will be so 4, 8, and then 3. Sorry, it should be 3 at the bottom, but somehow, okay, then I should probably change my drawing to something that looks like this. Right, that's much better. This is 3, this is 4, and this is 8. And the answer is 3 plus 4 plus 8, which is 7 plus 8, so the answer is 15. Yeah, same goes for the diagram on top. Draw it again. This is the marked corner. This is the bottom. It looks a bit strange. I know that's because it's consider it's concave. Okay, it's inside the paper, not pointing outside the paper. Usually for this one, it's the corner is pointing outside the paper, but for this one, the corner is pointing inside the paper. If you imagine it like that, it'll be more comfortable. And this is 4, this is 5. Okay, let's look at the next question. All right, there's still a final question. So the same cube is rolled, so a 10 is on top. Fill in the missing sides so that the sum of the faces that border faces this border with the marked corner is 27, meaning we want all 3 faces over here to add up to 27. So what are all the faces we have? Let's see. So we have 3, 4, 5, and then we have 8, 9, 10. Yeah, 3 plus 10 is 13, 4 plus 9 is 13, and 5 plus 8 is 13. We have 3 over here. We just need to pick two numbers that adds to 17. Okay, and the only 2 numbers that adds to 17 is right here, 8 and 9. Okay, order doesn't matter. You can write 8 on the left or on the right. Doesn't matter. Just write 8 and 9 on the blank, and we're all good. Is there any other possibilities? I think there isn't. 5 plus 9, no. 4 plus 9, no. 3 plus 9, no. And the rest will definitely be less than 17. So that's it. 10, 8, and 9. Then moving on. Question C. The same cube is rolled, so an 8 is on top. Write down all possibilities for the sum of the missing faces that border with the marked corner. So let's draw the unseen faces, shall we? Okay. So the top face is 8. Then the bottom face is bottom face must be 5 because 8 plus 5 is 13. Okay, and then we want 8, plus this side, I'll draw it in, outline in red. Okay, the side on the right and the side on the left, plus these two sides. Okay, again, we can find out, so 3, 4, 5, 8, 9, 10. Cross away 5 and 8 because they cannot be our choices. As long as you don't have 3 and so number pairs 3, 10. As long as you don't have 3 and 10 on both next to each other as close neighbors, we're fine. Yeah, because 3 and 10, they must be opposite faces. Okay. So we can have 3 and 4 as neighbors. Right? We can have 3 and 9. Right? The other side is 4. We can have 4 and 9. Oh, we cannot have 4 and 9, sorry. We can have 4 and 10. And finally, can we have anything else? Let me have a look. So if we have 8, 3, and 4, the answer will be 15. If we have 8, 3, and 9, the answer will be 2 more, which is 17. Oh, 5 more, so it's 20. If we have 8 plus 4 plus 10, we will have, this is 22. And yeah, we can have 8, 9, and 10. Yeah, that's right. So 8 plus 9 plus 10. That is 27. Well, another way to think of it is you can write down all the possible combinations. Yeah, four numbers over here, 3, 4, 9, 10. Pick out 2. We can have these combinations: 3, 4, 3, 9, 3, 10, and then 4, 9, 4, 10, 9, 10. Yeah, that's it. That's all 6. And then take away the ones where we have number pairs as neighbors. So 3, 10, they cannot be neighbors, and 4, 9, they cannot be neighbors. So these are all the 4 possibilities: 3, 4, 3, 9, 4, 10, and 9, 10. Okay, 3, 4, 3, 9, 4, 10, 9, 10. And then add the 8. Yeah, that will be the 3 faces we have. Find the sum, get the answer. These are all 4 possibilities: 15, 20, 22, and 27. And we have one last question, and then we are done here today, everyone. So for this question, we have symbols. Okay, symbol plus symbol equals to symbol. Okay, yes, Jeremiah, you have a question?
Can I go back stuff and finish writing it down, please?
Oh yeah, I will send these notes as PDF to you after the lesson. All right, so don't worry. You will get these. You will get these pages as if you want to complete your notes. Don't worry.
Thanks, mate.
Don't worry. Yeah. And last question. So with these type of problems where we have symbols plus symbols equals to a symbol, and it's not symbols plus symbols equals to numbers anymore, it's not easy for us to just deduce like this, the first one is equals to 5, the second one equals to 6, and so on and so on. Cannot, okay, not doable. Then I recommend that we use the method called setting numbers, assuming. Yeah. We have introduced this method, I think, at the first lesson in autumn term. Let me just get the lights back on. 1 minute. Oh. So it's from first lesson in autumn term. It's assuming that this symbol, these circle plus circle is 1. Okay, circle is 1. This circle is 1. Yeah, I'll call it the forbidden sign. Okay, forbidden sign plus forbidden sign is a square. So forbidden sign is 1, and 1 plus 1 is 2. So the square, a hollow square, is 2. And then forbidden sign is 1 plus a full square. We don't know what full square is, and we don't want to assume, right? We don't want to assign a new number to it. We want to use this 1, Yeah, and then try to represent all the other numbers. This is 2, hollow square, we know that. So 1 plus black square equals to 2 plus dotted circle. Okay, this is a relationship, right? Put it there, don't bother. Because we cannot go any further without assigning a number, another arbitrary number to the black square and the dotted circle. And then dotted circle plus this square with a cross in it equals to 2 plus this, 2 plus a black square, okay? And this is equation 1, this is equation 2. If you have a look at these two equations, we can add them up. So 1, which is the forbidden sign, plus there's a black square on both on left-hand side and on right-hand side. That tells us, that means we can cancel them out. Yeah, we don't need to consider them. They have no effect on the equation. And same goes for the dotted circle. They can also be canceled out. So that gives us 1 plus the square with a cross in it equals to 2 plus 2, which is 4. So the crossed square equals to 3. Yeah, this is 3, which is good. So the last one, we still need to find the black square and the dotted circle. We cannot find the exact value for these two, but we can find a relationship between them two. Take away 1 from both sides of the equation. That gives us a black square equals to 1 plus the dotted circle. Okay, this is the relationship between them. So let's see. Let's try to answer the questions. A square minus a forbidden sign. The square is 2. Forbidden sign is 1. It's a 1, but we need to give or answer in one symbol. Okay, we need to write symbols for the answer. So write the forbidden sign over here and erase the 1. Okay, and then question B, forbidden sign plus a square. Okay, forbidden sign plus a square. This is 1, this is 2. It is 3, but we need to write in symbol. Which symbol represents 3? The crossed square is 3. Okay, that's question B. And then for question C, the forbidden sign is 1 plus the dotted circle. Yeah, 1 plus dotted circle looks familiar, which is this one over here. We have an equation. It's on the left-hand side. It's on the right-hand side of the equation. We can just take the symbol, the black square on the left-hand side of the equation, and then put it as our answer. Black square. Okay. Yeah, that is all for all of the questions in St. Paul's and City of London. Thank you for coming, everyone. That is the end of our office hour today. If you have any questions, you're free to ask them now. If you have not, I will end the meeting and see you the Wednesday after next Wednesday. Yes, Cindy. Oh, where is Cindy? There she is. Do you have a question?
Yeah, 2E. Can you like
2E,
explain
yeah.
2E? Also, would you send the PDF to?
Yes, I
Rachel?
will. I will send the
Okay, thank you.
PDF version of. Let me just get back to 2E real quick. Is it this one? This one over here, right?
Yeah.
Okay. So if you're not happy with the general term method, sure, no problem. We
Wait,
can
no,
use the
2E. Wait, I
2
think it's 2E.
2E.
Yes, 2.
Okay, so this is 1E. Not what we're looking for. This is 2. B, C, D. Ah, this one right here, right?
Yeah. Yes, this one.
Yes, okay.
Yeah.
So the reason why we can solve 2E real quick is because the question is actually preparing us to solve this question E using the previous question. You see, in the previous one, we have question
Yeah.
B, find the value of N401 minus N400. That tells us the difference between the value of N401 and N400 is just 401, okay? And then question C, that tells us we can find the the value of O something quickly by just taking that number on the bottom right and then square it. Okay, that will be the sum of all the odd numbers. Yeah, we can find that pretty quick.
Yeah.
And then question D tells us that we can split an even number. So N6, we can split into O3 plus E3. Okay, with all these known, we can solve this question real quick. Right, I just need to, get my pen back working again. So N200. So E100 is definitely it is obtained from over here. You see here, this equation N200 can be split into O100 plus E100. Right? The question is asking for E100, and then E100 must be N200 minus O100. These two are all known or can easily be obtained. N200 is known. It is 20100. Sorry. So it's 20,100. Write it down here. And then O100, we can find the value pretty quick. It's just 100 squared, which is 1 followed by 4 zeros. It is 1. Then the answer is easy to obtain. Do subtraction between these two numbers. That will give us 10100 as the answer for E100. That is the first one. For the second one, for E200, we obtain it by splitting N400. Yeah, N400 equals to O200 plus E200. Okay, then E200 here equals to N400 minus O200. We know N401. We do not know N400, but we can get N400. Yeah. Because N401 minus 401, 401 minus this number gives us N400. Okay, so N400 is, we know N401, it is 80601. So 80601 minus 401 equals to N400, which is 80200. Okay, and then take away O200. O200's value is just simply 200 squared. So it will be 80200 minus 4 followed by 4 zeros. Okay, this is 200 squared. Yep. Sorry, I always write 5 zeros. And the answer we can get through observation is 40200. That's how we got the answer for the answers for question E.
Okay.
Yeah, and I saw Jaden raise his hand. Do you have a question, Jaden?
For question 16.
The City of London, right?
Yeah.
16. This one? Yeah, Jaden, this one?
Yeah.
Mm-hmm. You have a question? Which one?
II.
Oh, so the second one. All right. So the second one. Right. Let me just first ask Hugo. I'll come back to this question, Jaden. Don't you worry. So Hugo, do you have a question?
Yes. On number 5, on the St. Paul's Bills, I couldn't understand the number 5 as a whole.
Okay, number 5. Let me have a look. You mean this one?
Yes.
Okay. All right. So let me see, how much time do we have left? We have 5 minutes left. I'm not sure if I can go through all of them because this conference room ends at 7:30. So yeah, Jaden, I will explain that question to you. I'll send an explanation video to you. Have your WeChat.
Okay.
And let me just finish Paul's Hugo's question. Go through this again. So it's basically we don't have to find out exactly how much they are. Yeah, how much is forbidden sign, how much is square. It is impossible for us to find the exact values as well. So what we do is we, as I said, we assume numbers. Yeah, we assume. So this forbidden sign, I see it's pretty common. Yeah, it is in the first equation is in the second equation as well. So I just assume it is 1. Why 1? No reason. Just because 1 is a very convenient number for us to use. Okay, and then that gives us, from the first equation, 1 plus 1 equals to 2. Yeah, then the square will be a 2. Then now we know that the forbidden sign equals to 1. The square, a hollow square, equals to 2. And then from the second equation, okay, from the second equation, we get 1 plus the black square equals to 2 plus a dotted circle. Okay, this does not help us much, but it does give us a relationship between the black square and the dotted circle. Okay, it won't help us to find the exact value of a black square and a dotted circle. It only tells us the relationship, but that relationship will suffice. It will already be enough for us to find the answers for all the 3 questions. And then the meaning, why we have the last equation is because we need to find the crossed square. Okay, so we have dotted circle plus crossed square equals to square plus hollow square plus black square. Okay, and we have these 2 equations, the second one and the third one. If we add them together, because you see we have a black square on top on the left hand side and a black square on the right. We have a dotted circle on the left and we have a dotted circle on the right. All right. If we add them together, then we will have forbidden sign plus black square plus dotted circle plus crossed square. And that will equal to white square plus dotted circle plus black square. These are all numbers. Yeah, the symbols are representing numbers. We know that. And we remember from equations, the knowledge points, if we take away a same number from both sides of the equation still stands. So take away square, take away square, the equation still holds. Take away dotted circle, the equation still holds. So that tells us the forbidden sign, which is 1 plus the dotted plus the crossed square equals to 2 plus 2. So 1 plus crossed square equals to 4. The crossed square is 3. Okay, these are some useful information we know, and we can use these informations along with that relationship we have over there to solve the questions. Question number 1: what is hollow square minus forbidden sign? Hollow square is 2. 2 minus 1 is 1, which is the forbidden sign itself. And then question B: 1 plus 2, forbidden sign plus hollow square is 3. 3 is the crossed square, so just write crossed square over here. And then C, forbidden sign is 1. 1 plus the dotted circle. Looks familiar? It's over here. 1 plus dotted circle, which we don't know what exactly it is, but we know it is definitely the black square. All right? Yes, Hugo? You can just unmute yourself and ask the question.
Yes.
Yeah, Hugo?
Yes.
No more questions? Or is it clear?
No more. Clear.
No more. Okay, good. Jeremiah, I saw you raised your hand as well. You have any questions?
No, it's all sorted.
No? Good. So we good. And then I will end this meeting now. I will send you the explanation video later, Jaden. Remind me
Okay.
again which question that is again?
16-2.
16-2. Okay, good.
All right, bye.
And I'll see you the week after next week. See you everyone. Bye.